Azure offers multiple high availability options for VPN connections to ensure continuous, reliable connectivity between Azure and on premises network or between Azure regions. There are fundamental five design patterns that you can think of, such as VPN gateway redundancy, which is active standby mode, multiple on premises VPN devices, active Azure VPN gateway, dual redundancy, which is a combination of active Azure VPN gateway and multiple on premises VPN devices, and highly available VNet to VNet connectivity. Let's discuss each design pattern in detail. Let's unpack the design pattern called VPN gateway redundancy. Azure VPN gateway has a built-in redundancy. By default, Azure's VPN gateway operates in an active standby mode. This means there are two gateway instances set up for redundancy within a single region, but only one is active at a time. If the active instance fails, the standby instance takes over and minimizes downtime. The failover process happens automatically and ensures continuous connectivity. For planned maintenance, the switchover is quick, typically takes around 10 to 15 seconds to restore connectivity. For unplanned outages, like an unexpected issue or hardware failure, the recovery can take longer, around 1 to 3 minutes in the worst case scenario. This brief interruption is necessary for the standby instance to detect the issue and fully take over. For site-to-site VPN connections, means connection between your on-premise network and Azure, this switchover is usually seamless and the VPN reconnects once the standby gateway takes over. For point-to-site VPN connections, means like individual users connecting to Azure from their devices, the connections are disconnected during failover. Users will need to reconnect manually once the gateway is back. Active standby mode is suitable for cost-sensitive environments needing high availability without the complexity of active configurations. Let's discuss now multiple on-premises VPN devices design pattern for VPN connection. To add redundancy from the on-premises side, you can configure multiple VPN devices on premises and connect each to the Azure VPN gateway. If one VPN device fails, the other takes over. This setup improves resilience by eliminating single points of failure in the on-premises infrastructure. Each VPN device advertises the same on-premises IP prefixes to Azure through BGP. This enables Azure to forward traffic evenly through all tunnels simultaneously. While this setup adds redundancy for your on-premise devices, the Azure VPN gateway itself remains in an active standby mode. If Azure's active instance fails, it will switch to standby, which will cause a brief connection interruption. This design pattern is ideal when you need additional protection against hardware failures on the on-premises side. Let's discuss the design pattern called active VPN gateway. In an active VPN gateway configuration, both gateway instances operate simultaneously, creating two active site-to-site VPN tunnels to your on-premise VPN device. Each gateway instance is assigned a unique public IP address. Both instances establish a IPsec tunnel to the on-premises VPN device specified in the local network gateway and connection settings. These two tunnels function as part of the same connection and enable continuous data flow. To complete this setup, configure your on-premise VPN device to connect to both public IP addresses of the Azure VPN gateway instances. This will allow traffic to be routed through either tunnel. Both tunnels are active, so traffic between your Azure virtual network and on-premises network is split and routed through both tunnels. This setup helps balance the load and increases throughput. For a single TCP or UDP connection, Azure tries to use the same tunnel consistently when sending packets to your on-premises network. However, if a different route is available or preferred by your on-premise network, it could choose a different tunnel for its return packets. If one of the gateway instance undergoes planned maintenance or encounters an unplanned disruptions, the IPsec tunnel for that instance will temporarily disconnect. When a gateway instance goes offline, the corresponding routes on your VPN device are automatically adjusted or withdrawn and will allow traffic to be seamlessly rerouted through the other active tunnel. Azure handles the failure automatically on its end and maintain your VPN connection by switching to the remaining active tunnel without manual intervention. An active VPN gateway provides enhanced reliability and load balancing, which makes it ideal for critical applications that need continuous high-speed connectivity between on-premises and Azure. If any single instance fails, traffic is automatically routed to the other instance and minimize disruption. Let's discuss the design pattern called dual redundancy now. In this configuration, both Azure VPN gateway and your on-premises VPN devices are set up in active mode. This means that each side has 2 active gateway instances and results in 4 active VPN tunnels connecting Azure and your on-premise networks. Each of Azure's 2 gateway instances creates a tunnel to each of your 2 on-premise VPN devices. This setup forms a full mesh network, maximize connectivity, and offer multiple active paths between Azure and on-premises. Traffic is spread across all 4 tunnels. This setup provides load balancing and help distribute network load. This approach not only enhances redundancy but also offer improved aggregate throughput across the tunnels. For individual TCP or UDP sessions, Azure tries to keep traffic on the same tunnel for each flow to maintain session consistency. However, the total load is distributed across all tunnels and balance the workload for increased reliability. If any one of the 4 tunnels goes down because of maintenance or an outage, traffic will seamlessly reroute to the remaining tunnels and will help to maintain connectivity without manual intervention. BGP is required in this setup to manage routing dynamically across all active tunnels. It allows Azure to advertise routes to the on-premises network and vice versa and helps ensure efficient traffic routing. Remember, you will need 2 separate local network gateway in Azure, one for each on-premises VPN device. Each local network gateway will connect to both Azure gateway instances and establish the 4 required tunnels. This dual redundancy active configuration is ideal for applications that require high availability and resilience. With 4 active tunnels, this setup minimizes downtime and offers multiple paths for traffic and ensure that your network remains operational even if one or more tunnels experiences issues. The distributed traffic also helps with bandwidth optimization, though throughput may vary depending on application demands. This configuration is built for maximum reliability. Distribute load across a robust and fully redundant network connection between Azure and your on-premise infrastructure. Let's discuss the last design pattern called highly available VNet-to-VNet VPN connection. In a highly available VNet-to-VNet VPN gateway setup, you can connect 2 Azure virtual networks with active VPN gateways to ensure continuous connectivity and redundancy. This configuration creates a full mesh of 4 active VPN tunnels between the virtual networks, which enhances availability and reduces the impact of network disruptions. Each virtual network has an active VPN gateway, which results in 2 active gateway instances per VNet. Each VNet gateway connects to both gateway instances of the other VNet and creates a total of 4 active VPN tunnels. This forms a robust full mesh connection between the virtual network. With 4 active tunnels, there is always redundancy in place. If planned maintenance or unplanned event affects one tunnel, traffic seamlessly shifts to the other active tunnels and ensure high availability. Unlike cross premises connections, means like Azure to on-premises, which require two connections per gateway. VNet to VNet connections need only one connection per gateway to establish full redundancy. This simplifies the setup and reduces configuration complexity. For basic VNet to VNet connectivity, BGP isn't necessary. The default routing will handle communication across the tunnels. If you need to enable transit routing, means where one virtual network forwards traffic to other virtual network or networks beyond the direct connection, then BGP can be configured to dynamically manage routes. This highly available VNet to VNet configuration is designed for environments needing reliable, uninterrupted connectivity between Azure virtual networks. With 4 active tunnels and seamless failover, it's a resilient solution for Azure-based network architectures and provide a strong connectivity between virtual networks and also enable advanced routing if needed. That's all pretty much about all those 5 high availability options for VPN connections. You choose one or more based on your use cases. I hope you got now a solid understanding about those high availability options for VPN connection.